at B-sides, but effectively all it was different techniques that I use as a penetration tester to break into companies. These are what we kind of call the tricks of the trade, right? These are things that we use time and time again to break into organizations, and a lot of times it doesn't stop us. So these are techniques that I show with everybody else to kind of give a good example of different ways that I break in. These are one of many, but these are probably my favorites. About me, if you haven't heard, I left Diebold as the Chief Security Officer, and I started my own company called TrustedSec, which is located in Strongsville, Ohio. Basically, we do information security consulting, penetration testing, and all that good stuff, right? Created the Social Engineer Toolkit, and I actually have a book I'll hand out at the end of the day. Does anybody not have one of my books that's signed? Maybe not have one?
Oh, yeah. Sign one.
I'll hand one out. I'll sign it personally. On the backtrack development team, author of the Metasploit Penetration Tester's Guide, and a few other things out there. So again, as penetration testers, we have our own tricks that we use time and time again, right? Like, for the longest time, I used SQL servers as an attack avenue for internal pen tests, where I go in after the SA account and go after that. But I noticed a lot of companies starting to change that every time. So, we continue to evolve with different things to let us into organizations, and obviously, there's a lot of different types of threats out there and exposures that we have. Finding new ones all the time are very helpful. So technique one, everybody here has seen the Social Engineering Toolkit. Do you really know how the Social Engineering Toolkit works behind the scenes? So there's a few different methods that it does in order to compromise the victim or compromise the system. And these methods are redundant upon each other so that if one fails, multiple others can be successful. And I built that in the set for multiple reasons. One is, every time I release a new version of set, all the AV vendors go into it and they write signatures for set so they can try to get around it, right? So it's a continual cat and mouse game where I update my binaries and signatures, pack them, I obfuscate them, upload them, and I do a lot of different things every time you actually create a set binary. But a lot of times it's still continuing to play off of that. So if one fails, I have to have another method to do as well. If you notice, set was actually in the news. F-Secure released a new blog post that basically said they found one of the most advanced, pieces of Java attacks they've ever seen. It targets multiple platforms. It's highly skilled. The attacker was highly skilled. It was found out in the wild. It's the most advanced one they've ever seen before. I was like, hey, that's cool. And so I started looking at it, and it turned out to be set. And the reason I know it's set is because of the parameter name over here. I like hugs. So it's definitely set. And I put funny things in my code like that. And since then, obviously, all the AV vendors now rewrote all of the signatures for the Java applet. So what I did is, in the next version, 3.5, I obfuscated every single time with different things completely. Like, it moves everything around, shifts it all around completely every single time you use the applet. So F them.
But I bet you the string hugs is in there somewhere.
Yeah, I was going to say.
What's that?
Have they started just doing like a cache for hugs?
I'm just going to do search for hugs.
If you do a grep through the set directory and look for hugs, it's like everywhere. Your screen is just going for a while. So here's a quick walkthrough of the standard applet. So, can everybody see that okay, or make it a little bit bigger?
Bigger.
Have to keep it the same?
Bigger.
Keep it the same.
It looks good.
Smaller.
Smaller? Okay. All right, so this is our Java applet. What we're going to do is we're going to select one for the social engineering attacks. I'll zoom in now. I'm just kidding. All right, is that better?
Yeah.
All right, so we're going to select, we did one first, and then we're going to go to the website attack vector. Since I don't have internet access here, we're going to do a little bit different. We're going to go after the Java applet attack method, and we're going to use templates, but typically you can go and clone whatever website you want to, right? So we're just going to go to web templates, and it's going to ask for my IP address. Enter that in. And then we'll just use a template of Gmail. And so it's just going to go ahead and rewrite all the stuff for us. And with the new version, it's 100% dynamically generated in custom now every single time. So there's nothing static in it.
What
in
was
this method,
what was the Java required one?
Java required just loads a website saying you need JavaScript in order for this page, or you need Java to accept the Java applet in order for this page to load properly.
Okay.
Just a fake looking website. And so we have a few different methods here. We have a standard binary dropper, and what happens with this is when the Java applet is clicked on and someone hits run, Okay, the Java code behind it says, well, what platform am I running on? Am I running on x86? Am I running 64-bit? Am I a Windows machine? Am I a Linux machine? Or am I an OS X Mac machine? If it's any of those categories, it goes and does different things. So if we use the binary dropper, what it'll do is it'll go out to the set web server. It'll actually pull a binary down, right? And then it'll execute. So download and execute type attack, right? Now, obviously, the problems with this, and I think I'm jumping ahead on my slides, who cares? The problem with this method is obviously you're dropping a binary on the system. So antivirus techniques, things like that are going to go kind of out the window because you're going to possibly be detected, especially if it's a Metasploit method. Now, there's a couple things that I do inside of set to make it look more of a, like a believable binary. Like for example, I'll take an executable and I'll grab it, I'll obfuscate the heck out of it, I'll change a couple of the memory page addresses and stuff like that, the entry points, a few other things. And then I'll also hack it using UPX. And then I'll obfuscate the UPX a bit, because it puts like a lot of UPX flags and stuff like that in there. Remove all that, and then I do what's called digital signature stealing, which when Microsoft releases a patch, it signs it with a digital signature, or a certificate. So things like SCCM and things like that can automatically go and deploy it. So if you right-click on, like a service pack or a hotfix or whatever, and you hit properties, you go to, you'll see an extra tab that gets created called certificates. If you click under there, it'll show a valid Microsoft signed certificate on that binary. What you can do is, Didier Stevens came up with a technique called DISIT tools, which allows you to extract the digital signature certificate from the executable and import it into the other binary. And in that type of case, it makes the binary look legitimate in nature, like it looks like it's signed by Microsoft. Now, the certificate itself has a certificate mismatch because it's not the same CRC checksums as the normal executable, right? So you're going to have a mismatch, but at the same time, as far as antivirus is generally concerned, it looks like a legitimate Microsoft one. Things like Symantec, for example, a lot of times will not look at the actual binary itself and skip past it if it's running a digital certificate. So different ways of getting around different types of technology. But again, when this comes out, when things come out like this, they write signatures to go and go after that one. So we have problems with that. The second method is called shellcode exec, which is right here. Option number 14. And what shellcode exec does, has anybody here used things like, what's the
System terminals?
No. How did you get system terminals? I haven't even said anything. It basically, when you send an email in, it actually virtualizes it, looks at it, and a bunch of stuff. Sandboxes it and all that good stuff. What's it called? FireEye. Yeah, things like that. What the hell's going on with my cable? Things like FireEye, what they do a lot of times is they'll take a binary when it gets sent via email. It comes in, they sandbox it in a virtual environment, like a virtual Windows machine, right? They run it, and they see what registry calls it makes, it sees what type of internet connections it makes, it sees a bunch of different things to see if it's actually malicious in nature, right? And so, in the shellcode exec case, when you actually send this binary through, there's nothing malicious about it. It's just a binary, it doesn't do anything. When you double click it doesn't do anything. It doesn't have any network capabilities, doesn't have anything that it needs to use for it, because what it does is it basically it's a command line tool that takes a second parameter, and that parameter is alphanumeric shellcode. And so you can shove whatever program you want to straight into memory without ever having to touch disk. So a lot of times these executables get completely past AV or past any of those type of preventive technologies because it doesn't really do anything, right? You have to actually pass it second parameters. And that's what the social engineering toolkit does. Same concept as before, right? It'll go onto a system, they click run, they select run, and what happens is it goes in and downloads shellcode exec binary, and then it downloads it onto the system, an executable. And then it sends a second parameter for alphanumeric shellcode that ends up running, and then all of a sudden now you have a compromised machine. So we'll go ahead and select that one. And so it's going to go through and generate all of this stuff. Now I actually haven't tested the new applet, so this could be completely broke. This is 3.5 that I'm running here. It's not released yet, so it's still very buggy. And then the third technique it uses is what we call PowerShell injection. And this is the coolest thing ever, right? This is where we really get around anything that we have to worry about. We don't have to worry about binaries, we don't have to worry about anything. The only thing that we need is PowerShell to be installed in the victim. And PowerShell by default on Windows Vista and Windows 7 is out there, right? So on Windows XP machines, a lot of people even install that too because there's a lot of applications that don't work without it. So in most cases, you're going to find PowerShell on machines. Now what set does is when you run the Java applet, it looks to see, hey, are you Windows? Yes. Are you running 64-bit or x86? Okay, x64. Okay, do you have PowerShell installed? Yes. Okay, now I'm going to drop this payload onto the system using just pure PowerShell. And what it does is basically it uses, it grabs base addresses from kernel32.dll, it does virtual alloc, which allocates memory to the stack, and then it reads in shellcode to basically execute on the stack itself and never touching disk. So you're not dropping a binary, you're not dropping anything. It's just straight up execution of shellcode, and it completely evades anything that's out there. At least that I've seen. I haven't seen anybody stop this attack yet. So we'll go ahead and run it. So we see here we get the Gmail sign. We have some, there it goes. So we're gonna hit run. Okay, so I jacked up the stuff here, but that normally what would happen is you'd get a shell. So that's 3.5. I jacked the shell for sure. I rewrote the whole Java applet from scratch, so it's something I tested.
Did they revoke your trusted company cert?
No.
It was not.
Oh yeah, I didn't sign it with that here.
Okay.
Yeah. I'll do the job required one. And what he's referring to is 2 years ago, or a year and a half ago, Java released an update where when you sign certificates, self-signed certificates or Java applets, it shows a big unknown. And basically it's a big warning saying, hey, this could be bad. So I registered a LLC in the state of Ohio called Verified Publisher so that I can go buy a code signing certificate called Verified Publisher. And then when people click on it, it looks like a legitimate certificate, right? Assholes. Almost done. So we're going to go back to the site, and there you go. So you can see the verified publisher right there. It's not going to work. It's going to throw an error again and crap out, but oh, maybe not. Maybe work now. No. So normally what happens is you get some shells. I broke it profusely. So on the PowerShell side of the house, this is what it looks like, the command that you're actually looking at. What's going to happen here is it's going to go ahead and take the code, it's going to Unicode it, base64 it, and then do a bunch of stuff to it. And this is actually what's being executed on the system. Looks something like this. And there's the actual PowerShell command right there. So you can see up here, we're not using any profiles, we're using Windows style is hidden, so it doesn't pop up to the user. It's not interactive, and then we pass encoded command, which is a parameter that Microsoft built into PowerShell, which is kind of an interesting one. I mentioned this in the B-side talk, but Josh Kelly and I released an attack for PowerShell at DEFCON 19 or 18, it was 18, that circumvents what we call restricted policies, right? Is that what it's called? Execution restriction policies, thank you. So it stops execution restriction policies. And what execution restriction policies in PowerShell are supposed to do is stop programs like this from running. And so you have signed, unsigned, execute, a couple other permissions that you can do with execution restriction policies. And what you can actually do to bypass it is you can take your whole program, Unicode it, base64 code, decode it, and then run encoded command, and then you basically circumvent the execution restriction policies, and you can run whatever you want to on the system, a full application and program everything, so it doesn't really do any good. So you can see, I'll pop this in here real quick. copy it, and then we get a listener real quick.
Any idea what Microsoft has fixed problems with PowerShell? Just the fundamental, or?
I think it's built into the core of the functionality of how PowerShell works, and I don't necessarily know if they think it's a bug. I don't know.
So it works the same way with PowerShell 3.0?
Yes, it does. Yep. So we're just gonna go ahead and paste this whole thing in here. We're gonna enter, and over here we don't get a shell. Oh, this is all for 135. God bless it. You guys ever have it where VMware just keeps changing your? 130. One more time. I've actually only had one beer, so I'll just throw it out there.
One day.
One day, one beer. And I don't get a shot. Oh, there it goes. Sweet. So I did get a shot. So you can see here, just by executing that command, we have full access onto the computer, do whatever we want to. So it works, basically platform independent, as long as you target the specific operating versions. Now, this specific attack is very dependent on x86 or 64-bit architecture, so you have to make sure you get it right because we're dealing with memory. Any questions on that? So again, the first attack. All right, so the first attack, again, parameters are injected straight into HTML code. So what happens when you run the Java applet is it goes and it looks for parameters that are in the HTML code itself. And the reason being is it has to be dynamically generated every single time I do it. So I stick that all in the HTML code versus the actual Java applet itself. So I can completely randomize everything in the HTML code, pull those parameter arguments, and then use that to actually attack it. Again, obfuscate every single time, parameters are used every single time. Okay, method one, the binary dropper, somewhat unreliable because you don't know what you're going to do when you get picked up of it. The shellcode exec method, still not a good method because you're dropping a binary into the system. Obviously, our PowerShell method is the one that we want to go with and actually go through it. So, when I showed you two different attacks using binary dropper, right? Shellcode exec and standard binary. What if you need to get an actual binary onto the system and escape any type of antivirus and things like that? There's a couple methods that you can do. The first method is you can modify basically Metasploit PE templates. And you can have it obfuscated that way. And a lot of times there's Script Junkie has a really good post on how you actually do that. But you can basically modify the actual exe templates to actually have a different type of Metasploit binary drop that doesn't get picked up by AV. But that's still kind of a pain in the butt, right? So this is a very, very easy way of doing it. This is called, the guy that wrote it's called Christian Amann from Null Security. And he released this thing called Hyperion. And it was started off as a PowerPoint presentation like a year ago. But he just released the code about 4 months ago. And Hyperion, what it does, is it takes your standard PE file, whatever Metasploit binary that you have that would get picked up by AV, and then you run it through Hyperion, and what it does is it actually encrypts the whole PE file in AES 128-bit encryption. So you have basically an AES encrypted PE file that doesn't get picked up, and it's a completely different, unique key every single time. Now, at that point, when you actually run it, if you watch in Task Manager, it'll spike up to 100% because it's actually brute forcing its own key. So it's sitting there brute forcing its own key until it can figure it out, and then it decrypts it on the fly for you. So, and it's a weak, obviously a weak AES key. So we'll show you a demo of that real quick. So what we're going to do first is we're going to generate a payload. And so let me get a real IP address again. So we're going to do 128. So I'm going to do MSF payload, Windows interpreter, first TCP, lhost equals 192.168.128, L4 equals 3, and then we'll just create a standard binary. So we're just creating a simple exe. Then we're going to move that exe It's my desktop. And I can't even see it. I can't even see that folder. So I'm going to take mood.exe, I'm going to copy it over. To my Windows XP box. I'm going to copy it to the Hyperion directory. And all you do is you type crypter, and it says input file, output file. It's as easy as it goes right there. So we do crypter, do mood.exe, and then do mood2.exe. And so it's going to go through and do all this cool stuff. It's done. So we'll watch Task Manager here. Let me get a listener up real quick. So I'm just creating a listener so that when I initiate it, it'll call back to me. So we're ready to go. On this side, you notice here is 0 CPU usage. We're going to call the executable. You see it spike up to 100% as it's brute forcing the AES key. And then it brute forced the AES key successfully. Go back to our attacker machine. We don't have a shell. We should have a shell. So. Anyways, normally it works. It worked in my demo and it sense, I swear. Easy, huh? And interesting enough, last time I checked, and it was like a week or two ago, when I took a Hyperion-based PE file, it still wasn't not getting picked up, period, by any of the AV vendors out there. So 0 out of 42 were picking it up, which is always a good thing. So a lot of times, as penetration testers, when we actually go in and break into a company, people do strict egress filtering, right? So you don't allow a lot of outbound traffic. The reason being is, you know, it's easy for a user to click on something like the Java applet, but it's hard to find your way home outside of that network to get access back to the attacker machine. And so last week, I released a new tool called, well, it's an extension to a tool I'd already written, but it's called Egress Buster Reverse Shell. And what it does is, when the executable, or whatever it ends up being, is initiated, it brute forces every single port on the firewall until it can find a way out. And so it's got a server sitting on the outside, it's got a client machine, and it hits every single port until it can find one out. And then once it finds a way out, it then establishes a full command shell to you. So you basically have full access to the machine. It is noisy, very noisy. You know, no one ever seems to see it, so that's for me.
It's theoretically noisy.
It's theoretically noisy, that's a good one. That's about right. And it's fast too. Talking, you can do, you know, 50, was it? I always get confused. 55,000. 65,554.
35.
35. I won't remember that tomorrow. So
In what time?
what's that?
In what time? I think that was the rest of the sentence.
5 seconds?
Oh, sorry, yeah. It takes about 5 seconds per 1,000 ports.
Well, that's not. So, about 40 minutes. 5 minutes.
About 5 months. A little over 5.
So what we're going to do is we're going to create a quick listener. Egress listener. And then basically it just wants to do ports. I'm just going to do one port because I have all my ports open in this box. And so it's listening right now. Then over here, we go 192.168.225.128, and then we're going to do port 21. And then, notice as soon as we send the packets, we get a full command shell to this person's machine. So we have access to it. So basically, a lot of times what I'll do is I'll use a download and execute, because a lot of times when I'm doing a social engineer attack against the company, a lot of times you only have one shot, right? You're not going to have multiple entries to get into, because a lot of times your spear phishing attack is going to get picked up eventually. People send the communication out, you get less clicks. So what I usually do is I'll either go in after one person, very targeted, to see if I can get a port out, or all I'll do is when this actually establishes connection, it downloads an obfuscated binary or PowerShell or whatever, and then drops it onto the system so that I now have full access on that port. It does it automatically. So I can say, based on connection port, use that to create the binary, upload it to victim, download and execute, and then you're all set. So you don't have to worry about anything else going on. And by the way, obviously I wrote that last week, and there's no antivirus vendors picking it up, so it's still free to use, no antivirus warning. But so really easy to use. Now, one of my personal favorites, and they were just talking about this earlier, and this works on everybody, which is awesome, is using group policy against the attackers. So when you go and you do a pen test, right, there's a number of situations and scenarios that you find yourself in. One is you maybe have a local admin account and you can't get over to a domain user account. But in most cases what happens is you have a domain user account but no permissions whatsoever. You can't get admin accounts, you can't get domain admin, you can't get all of these things that you do as a penetration tester. And so you're kind of stuck. You're in a little loophole where you can't gain further access to the systems. And so the guys at Spaghetti, ESEC pen test, here's the link to it right here. They did some research and it's so funny.
That link didn't actually work. I did Google Cache code.
I took a directly from their site, so I'm not sure. Maybe it's down or something?
Yeah, I tried it. I know it was Monday morning. I was trying it right before I got in. So maybe it was just down at that time.
Yeah, it could have been, I don't know. Not sure. So the attack is really easy. As a domain user, you have access to the sysfile share on a domain controller because you have to pull down your policies, right? Every computer, every domain user has the credentials and ability to go into the sysfile share to be able to start extracting information off it because group policy uses that to pass things back and forth. Now you go under the sysfile share and you head to the policies folder and you go to the machine preferences group. There's a group.xml file there, groups.xml right there, okay? And there's some weird GUID. You have to figure out what GUID is under. It's unique every single time. Groups.xml. So the contents of the file is something like this. And in there is a variable, or parameter variable, called cpassword. And that is some sort of crazy encrypted string, okay? So it's an AES encrypted string, right? Well, unfortunately, Microsoft put the static key up on the TechNet site, and that's global across everywhere. So anybody uses Microsoft has this exact same static key. And that cpassword variable is your local admin password that you set through your policy. So you're able to basically, as a domain user account, go into that group policy setting and get the cpassword variable and then decrypt it, which is your local admin for your entire organization. So very easy to do. It's the key right there.
Well, at least they made it public so that no one had to crack it.
Yeah, I know.
You know, because then now it's available for everyone.
Right, it's share the wealth, share the wealth.
Why didn't they at least, encrypt the hash? At least that way you have to break it if you, crack it.
Why did this
Like,
go
do
wrong?
something.
I don't know if there's really a reason for it. That's the Python code to do the decryption. So just copy that and you can decrypt. That's on the EditedPracticeDefconTalk website, by the way. Here's the actual decrypted password when you run that Python code. It can be as complex as you want to. It doesn't make a difference, right? And so it's funny because group.xml sucks, but they also store a bunch of other stuff too in the C password variable with that same static key. So the guys at RootDance went and looked through, and they store everything from scheduled task passwords to SQL service passwords to like a bunch of other stuff. So there's basically a ton of passwords you can jack straight from group policy and not have any type of permissions whatsoever with it. So here's a list of all of the other affected areas right here. Right. So there's a ton more of these that I can keep going through. This is just the ones from the B-sides. Can you cut that for a second?
Audio or video? Everything?
Everything. No.
Yes or no?
No. Yes. Where is the? Come on, you like it, Dave.
I love it.
All right. So if you go under the source code for Egress Buster, literally this shell is stupid easy. It's right here. That's the shell. So it tries creating a going to a port and IP address, and then basically this is the shell right here. While one receive data back, which means that hey, I'm establishing a connection, and you can make it whatever you want to, so it's an actual account authentication type thing. And then if data is quit, then break out of the loop and then exit the application here. Then it does proc equals subprocess. Process is just a native Python library for doing command shells, right? So a command prompt. So basically, I just loop through and send out the output from proc with the command that I receive every single time from my attacker machine. It's that easy. So in most cases, it looks like different traffic. It doesn't really look like a command shell. It's standard Python libraries. But I mean, you can make it look whatever you want to. Like if you look at the AES shell, let me see if I got that here. I'm not sure if I have that here or not. Let me see. Oh wait, it'll be in set. Hang on. This is the HTTP shell set that communicates purely over HTTP. What it also does is it communicates via AES 256 encryption. So what happens is the protocol itself communicates via HTTP, post and gets. Okay, so back and forth, post and gets. Now what happens is your command shell data gets encrypted via 256 AES. It's a static key. It's actually right here. You can change that to whatever you want. What's that? Yeah, hug. Maybe it have to be hugs. A lot of hugs. Yeah. But what happens is, so when it's about to send it, it base 64 encodes it and then chunks it up in a small portion. So it looks like legitimate HTTP traffic, and it shouldn't get flagged by any type of behavioral analysis. So just a matter of how you want to go about it. You can do the same type of thing where it says, it says if goes out port 21, use the FTP shell. If going out port 80 or 443, use the AES HTTP shell, so you can actually get protocol specific, and that's actually not a bad idea. Maybe I should just write that in tonight. I think I will, honestly. Make a note. Yeah.
Don't you have other bugs to fix?
Yeah.
That's not fun though.
All right, can you pause that again? Seriously, can you pause that again?
Oh.